review and where they are in the planning. Masaki.
Okay, MMX, it's a Phobos sample return mission. And for us, it has a flavor of an asteroid mission because if you think about what Phobos is like, it has a strong link to those small bodies born outside the snow line. So MMX is it's really like a brother mission to have the two. And it also has an engineering challenges. It's a good opportunity for us to elevate our engineering capability. And especially it's the first round trip to Martian systems. And we're also going to try a more sophisticated sample retrieval technology, which I will tell you more details later. So this is the mission profile, launch in 24, and get it 1 year later, you arrive at Martian system. And then you stay there for 3 years, and during that 3 years, that 3 year includes the landing operation, landing on the surface, staying there for a couple of hours while we do the sampling, and then come back, depart from the surface. And then another 1 year later, we come back to Earth, so the sample will be returned in 2029. This is what the spacecraft look like. It's a big spacecraft, at least in our standard. Then it has a modular configuration: propulsion module, return module, and exploration module. And but the size of spacecraft is something like this. Okay. So then about the instrument, there are 7 instruments on board, and I think top 3 are like the camera, wild field of view, and then the telescopic one. And then a near infrared spectrometer, which is coming from France. And then the gamma ray neutron spectrometer coming from the US. I think these are the 3 key instruments, and then others are like a laser ranging instrument, dust counter, and then the ion mass spectrometer. So but now, this is a sample return mission from Phobos. What does it look like? As I said, it's going to land on the surface and stay there for a few hours. So we don't do that. It's not a touch and go mission, so we don't do this bullet shooting sample acquisition, but instead we do something more sophisticated, which is sampling using this Quora system. The Quora is sitting on the tip of this manipulator, and this manipulator can move around and pick up the best sampling spot beneath the spacecraft, and then this Quora will be inserted into the canister inside the spacecraft, and then brought into this the sample return capsule. Sounds like a bit complicated mission, so it would be nice to have an independent way of getting the samples. So that's why we are having a pneumatic sampling system. This pneumatic sampling system works as long as you land on the surface, more or less, because as long as you have the foot pad on the surface of the asteroid, you can get the sample. And this technique is more or less the same as the one utilized for the OSIRIS-REx mission. And it's coming from the US. Why is that working? Oh. Oops. Okay. And we also have a plan to have a rover, mini rover from Europe. It's Knes and Dila who's leading this study. And the size of this rover looks like this, 40 centimeter times 50 centimeter. Its weight was, initially we gave them 10 kilograms, but now it's like 22 kilograms, which still we can accommodate this. So it's a 22 kilogram rover. And you might wonder, can it really rove under the microgravity? And the study shows that it can rove at the speed of 1 millimeter per second, which is not that bad, because originally it was supposed to be 0.1 millimeter per second, so speeding up by a factor of 10. And then, this guy will be roving on the surface and giving us crucial information. Like like the data from Raman spectrometer. No, you know, the rover is on the surface, so you can illuminate the surface and get the scattering signal back. And we could have thought about the APX, but given the nature of the Phobos, you know, should be more carbonaceous, more interested in organic materials. The choice was made that we should have a Raman spectrometer on this French-German rover. So yes, MMX has a full suite of international collaboration from Germany, from ESA itself, through this support for the data downlink, which is the same for Italy. And then France is leading the two elements, especially the two elements, the near infrared spectrometer as well as the small rover. And of course, you know, usual suspect, NASA, you know, it plays a great role in this mission as well, of course. And about the recent progress, one of the biggest issues is the planetary protection categorization. We have managed to win the unrestricted categorization for this mission. Why do we care? We care because you know, Phobos is orbiting rather close to Mars, and when there's an impact event on the surface, some debris might reach the surface of Phobos. So there may be some Martian materials, Mars sample, piling up on the surface of Phobos, which we may sample. That's something really good. You know, this is a Phobos sample return mission, but has a flavor of Mars sample return mission. But at the same time, that makes you worry that there is a possible delivery of microbes from the Martian surface to Phobos. So we have to make the argument that the risk of bringing those things, you know, back from Phobos is less than the acceptable risk. No, which is it less? I don't know. Well, the risk is small. So we have made an argument, you know, by Japanese scientists as well as great support from our international partners. And then at the COSPA Planetary Protection Panel, we submitted our report to the Planetary Protection Panel, and then the conclusion is that MMX, Phobos Sample Return Mission, performed in the way MMX does, should be regarded as unrestricted Earth return. If you do it in a different way, like if you bring the whole Phobos back to Earth, it's going to be regarded as restricted Earth return, of course, but, you know. And then what's going on now, another big event that happened recently is the selection of where is it? The conclusion of the request for proposals. The manufacturer has been selected to Melco, Mitsubishi Electric Company, not NEC. NEC was the biggest supporter for us, but this time it was through the fair selection process. Melco is now selected. And then it's going through a heavy front-loading process now, and the project is finally approved. Within JAXA, the project is finally approved, and the real start of the mission is ongoing. We still have to fight for the budget, of course, but within JAXA, it's kind of approved already, and I'm moving on. So some science discussion. When you look at Phobos, the most obvious feature you see on the surface is this blue train, and you wish you can explain where is it coming from. And I think a team of early career people at my institute have managed to come to explain it, have come to an explanation of why we see blue train at this location here. I'm not going into details, but what I like about this is that we did have a team composed of astrodynamicists, regular scientists, and then spectroscopists who attack this problem. They have a diverse expertise, and they would not have even talked to each other if not for MMX. Because if you are not for MMX, maybe none of them would have stayed at my institute, and none of them would have spoke to each other. But they did, and it was MMX that was driving force to bring them together and work on this interesting problem. Possible explanation. So I really like this, gravity element of MMX. Once you have a nice mission, you can really grab nice young talented people. And MMX has been benefiting from survey already. So this is one of the meetings that was hosted by Miyamoto-san, talking about how to create the best what's the word? I forgot. Whatever. Some materials that really look like Phobos. Simulant again. Simulant, yes. How do you create the best simulant for Phobos? And then after this discussion, he visited Florida, and then learning through this kind of training session, his lab managed to produce a nice simulant. And that's really benefiting the MMX mission. And the MMX is a round trip to Mars, landing and sampling on the surface of Phobos, and possibly these samples includes samples of Mars. So MMX has a flavor of Mars exploration. So that led some of our younger team members to think about what should we do beyond MMX. What's the Mars exploration program we should have at JAXA? So there are multiple ideas that is under discussion. But basically, they think that the subsurface water system is the frontier that we should explore. And for that reason, they're really looking into a sounder to look into the subsurface structure down to like tens of meters. They're really interested in the top surface. And of course, they are thinking about drilling technology because, again, they think that going into the subsurface is the next frontier for us to pursue. But this is really something that's just being discussed now. And again, maybe through the survey framework, we can have some thrust into this direction. Yeah, thank you. That's all I have to say. Thank you very much.
Thanks very much, Masaki, and we are very proud to be helping you, and we'll do a lot more of that in the future. So are there any questions for Masaki? No questions? Mahesh?
So many great talks to ask questions. So you mentioned that Phobos has recently been classified as, the coast part, unrestricted sampling. On the other hand, if we say that it might have samples from Mars, does it change? Does it change the attitude? Does it change anything with regard to sample return?
Yeah, what's going on? Yeah, but that conclusion was made with some, how do you say, with a footnote saying that if we find, science is moving on. If that Phobos sample return mission, well, especially MMX, sample obtained by the way MMX does could be more hazardous than we think now. Maybe there might be a revision in the conclusion they have made. So the bottom line is that people don't think we know enough about the nature of Martian samples. So the process itself, how do you bring the Martian, the biggest uncertainty in that discussion is that the density of micro, what's the word? Germs.
Yeah, microbes.
How much microbe we have on the surface of on the Mars. That's the biggest unknown. So we give numbers referring to the result from the toughest neighborhood on the globe, like the Atacama Desert. And I think that's reasonable as far as we can tell now. But maybe in the future we may learn that number should be changed from some new scientific results. Then the conclusion they have now might have to be revised. So, well, that's not. That makes me anxious, of course, but I think it's a fair argument because given how little we know about that number, density of microbes in the Martian soil.
Any other questions? I actually have a question for you, Masaki. Have any simulations been done as to the cross-section of potential Mars material, on Phobos, simulations of what might have come
Yes,
up?
those mentioned we used in making the argument for the planetary protection.
Yeah,
And then there are some numbers from the previous literatures, but the simulation we have done revised the number, and we think we have more Martian materials on the surface of Phobos than had been thought before.
yeah,
But I didn't like it because that makes us tougher to go through the planetary protection argument. But even with that revised number, which tells you that we have more Martian material on the surface of Phobos, we could tell that we could pass the safety regulation of the COSPA planetary protection panel. So the short answer to your question is we did, and the number has been revised from what it had been before.
mhm.
Yeah.
Okay, all right, thank you. Any other questions? Penny?
Yeah, I just want to commend you for being so meticulous when you're contemplating the planetary protection aspects. Greg, I can't see around you. You are not transparent. Okay. But, so one of the potential snafus is somehow there's a discovery that there are surficial microbes indigenous to Mars while you're in the middle of all of this. What happens if it gets reclassified? Not that I think this is going to happen, but what if it gets reclassified when you're in the middle of the sample return? That would make it restricted return, but really we need to get on the track towards producing a place somewhere on Earth or some places on Earth or maybe on the moon where we can actually deal with potentially sensitive samples. And we all know that, and yet we're not coming to grips with it. So, it's eventually going to have to be the case that we handle sample return materials from the surface of Mars itself. So I don't know whether you guys are in discussions about where these materials could be received and safely dealt with, because we are in somewhat disarray, I would say, in this country about how we're going forward with dealing with that.
Yeah, for Mars sample return mission, the sample return capsule is designed in a way that however it crashes, it's not gonna spill over its content, which is not the case for this forward sample return mission. There's a limit to it. It's not as solid as the sample return capsule for the Mars sample return mission. So if we are told by COSPA that now they changed their mind, it's restricted Earth return, I don't know what we can do, seriously. So maybe we have to burn a spacecraft knowing that we got some samples, which is not a happy situation. But because it really has to do with the design of the sample return capsule, which is kind of frozen already by now, and I know which is frozen after launch for sure, of course. So yeah, I don't know. I really don't know. It's not can it become a political game? Somebody who doesn't like us just talk to COSPA and then try to jeopardize our exciting mission. Yeah, I don't want that. I trust scientists, but yeah.
Thank you. Thanks, Masaki.
Thank you.